Hello everyone, I'm Guillaume Toussaint, and today we'll talk about how to set up a GitOps continuous deployment and delivery pipeline for your application using only clone native and open source solution being the Argo project. So this is the kind of flow we would like to implement, each time a developer submits a change, it would end up in a Git repository, where from there we want to deploy this change automatically to a test server. Here we want like to then run some automated validation to ensure everything is fine with this new version. And if everything is fine, to promote this version to production, where we'll not open the new version to all the population of users in production, but only to a few percent. This is a canary testing mechanism. And then if everything goes fine, we'll roll out the new version to the whole population. So let's take a look at the demo platform. So we'll run that on a Kubernetes cluster. You can run it on any Kubernetes cluster you have. Where we'll deploy Argo CD, which is our GitOps deployment controller. We'll have Argo events and workflows who will take care of the promotion workflow. I will explain just after how it works. And Argo rollouts taking care of the canary mechanism. Then we'll deploy the application in two namespaces, one for test, one for production. And to have everything working, we'll have an infra namespace where we'll have the Docker registry to push the images of our application, and then Nginx controller to be able to access the endpoint of the application, and also route the traffic between the stable and canary version of our application in production, and the Prometheus stack to be able to monitor the application and check if everything is going fine. So let's take a look at the promotion workflow. How does it work? So usually what you would have is a GitOps repository. So it's just a Git repository where you will store all your platform manifests, your application, everything around. So in our case, we'll put there everything. So all the Argo controllers, all the infrastructure, and the application itself. And here we'll mimic what usually the continuous integration is doing. Usually it's creating some artifacts like a Docker image, a Helm chart for the application, and bumping the version in the GitOps repository. From there, Argo CD will watch the changes and deploy it in our Kubernetes cluster. And if everything is fine with the deployment, it will send a notification via a webhook hosted by Argo Events to create an event that will, with its trigger, instantiate a workflow that is run by Argo workflows. And in this workflow, what we will do is to run some tests, and if everything goes well, promote to the next phase. And then for the canary process itself, we'll do it only in production. And so how does it work? We have the stable version of the application, which is the 1.0. And we would like to load the 1.1 version. And so the end user will always use the same ingress to access the application, and Argo rollout will take care of routing a percentage of the traffic between the production version and the canary version using the Nginx controller ingress. So I have my Kubernetes cluster running here. So it's just a K3s cluster. You can do it with Kind or Minikube or any kind of cluster you can have locally, or you can do it with a real cluster remotely. So here it's quite empty. And the first thing I will do is to install Argo CD. So it's the only thing we'll do, not GitOps, let's say, to install Argo CD, and then we'll use Argo CD to deploy everything else on the platform. It will even deploy itself. So you can see it's deploying in a namespace called Argo CD. So once it's installed, we can access the Argo CD UI running locally, and then from there we can create a new application. So it's the only time we'll do an action in the Argo CD UI directly to create an application. Then it will work with the GitOps repository I will just give him. So just creating a project here. And then I will give it my GitOps repository. And the path where the manifests are. So you can find everything in the GitHub project that is in the description. So you can go there and understand how the manifests are created. deploying in my local Kubernetes cluster in the Argo CD namespace. Doesn't matter, it's just a pointer for the first application, then my manifest can define their own namespace. That's what they do, they create namespace and deploy inside them. And then clicking on create the application. So you can see it's creating many different Argo CD applications. So it starts from the root I gave it, so Argo project demo, and from there creating an application for Argo events, Argo rollouts, Argo workflows, Argo CD, so deploying and patching itself, the infra part, and then an application to generate my different application instances, so production and tests. So now we can see that everything was deployed and they are all synced and healthy. So it means everything was correctly deployed and they are in a good state. So we can see that in our Kubernetes cluster as well. So you can see all the pods that were deployed now. So we have the application, Argo workflow, Argo route, Argo CD. Okay, so everything is healthy. So now how do we implement on that promotion workflow? So we'll start from the picture here. You remember Argo CD was able to deploy from the GitOps repository to the Kubernetes cluster. And then we'll start by the end. So by implementing the Argo workflow running the validation and the promotion. Then we will come back to the Argo events to be able to instantiate those workflows. And once we have this link created, we'll create the link between Argo CD and Argo events by creating the notification in Argo CD to trigger the Argo events webhook. So first, let's check what the application is doing. So it's just a basic Quarkus application exposing a REST API on the /pet. And with the get method, it's returning a pet. So we'll build a 4 version of this application. The version 1 always returns dog, which is an allowed value. In our test, we'll run later. Then version 2, it will return wolf. Wolf won't be accepted as a pet because it's not a regular pet, let's say. So this will break our integration test. Then version 3 will return either dog or cat or bird, so which are all the values that are accepted as pets. And version 4, last version, will be the same as version 3, but we'll introduce some random error to make the API fail so that we can test our canary in production. So to be able to test that in the workflow resource here, I created the 2 small Python scripts, one to test the application, the other one to promote the application to the next phase. So the first one is just a small robot framework campaign targeting by testing REST and checking that the response is either a dog, a cat, or a bird. And if it's not, it's a failing test. And the promotion script is just a script to be able to bump the application from one phase to the other. And to do that, in the manifests of the application, we have the version that is defined in the value of the chart. And it will just take the version of the test on the commit that was synced in Argo CD and promote it inside the production values here. So usually you wouldn't do it like that. Probably you would bump directly the chart version if it's built along with the application. But let's say here it was more convenient to do it like that for the demo. So now how do we implement the workflow using those 2 small Python scripts? So if you check inside the resources, I just put a Docker file to build the Docker image from those Python scripts. And the workflow will just execute them and check if everything goes well. So I created here a workflow template that is basically running the test campaign. So I called it integration test. And it's using the Docker image I'm providing it. Test targets to know in which environment I should test. And then so it will run the script, and basically if the script is successful, the step of the workflow should be successful. I created another workflow template for the promotion. So same thing, it's running the script, and the script is taking some arguments, the Git repository to where to commit the changes or where to take the changes from. The source commit, this will be the commit hash synchronized by Argo CD, so it will be provided by Argo CD, this one. The source phase, so it will be test in my case, target phase, production. And then I can take the credential of my Git user from a secret I have in my platform. And once we have those 2 workflow templates, we can combine them in another workflow template, which is just chaining both and adding a condition to be able to run the promotion after the test. So here you can see in my workflow here called validate then promote, I'm running the integration test. So it's just referencing the other Argo workflow here, template. And I'm adding another one referencing the promotion. And we say it depends on the run integration test. So this step will run just after the run integration test, only if it's successful. So once we have all that, they are just, you see resources that are watched by Argo CD. So Argo CD is just deploying them in my cluster. So if I check here in my Argo workflows folder, I can find my workflows, my cluster workflows that were correctly deployed in my cluster. So synced, it means they have been correctly created in my cluster. Now we want Argo events to be able to instantiate those workflow, because here it's only a workflow template, so just a template of a workflow, but it's not a workflow itself, so it won't trigger any run. And so be able to have those templates run, we need to instantiate a workflow referencing those templates, and we'll do that with Argo events. So in Argo events, we start by creating an event source. An event source, it means it will be the source of the event triggering the action behind the scene. So in my case, it's a webhook. So I just say it's a webhook, give it a name, a port where it's listening to, and an endpoint, and a method, HTTP method, saying, okay, behind the scene, it will create a webhook at this part, with this port, which and expecting a HTTP post. Then I need to associate a trigger action with this event source. So it's called a sensor. I'm just saying, okay, it depends on a webhook. That it is called a webhook. With the event name inside the webhook called AppSync success. So remember it was inside the event source. And you say, okay, when I receive an event on this particular event here, I want to trigger what's below. So it's a creation of a Kubernetes resource. So with the operation create, and you see it's just a workflow. And I'm giving it the arguments here in the parameter taken from the JSON body of the notification, so of the webhook. So you see it's passing the body of the HTTP post to find the parameters it needs. And it's referencing my template, workflow template, validate and promote. So it will run this workflow defining this template, giving the parameters taking from the HTTP post body received on the webhook. Okay, so now we have a webhook, a way to instantiate the workflows that will run the test and promote the software. We just need to link that to a synchronization Argo CD has done. So how do we do that? So to do that, we use the notification module in Argo CD to be able to send a notification to the Argo events webhook. So to do that, we use the Argo CD config map called Argo CD notification CM. So it's an existing config map going along Argo CD. You just have to modify it to apply your changes inside. And you can say, okay, I want to define a webhook, and you give it a name, sync webhook, and it's using the event source Kubernetes service here. You see, you remember it was a port I've defined with a content type JSON, and then you can put different templates for this webhook. Here I'm just defining one in case there is a synchronization success in my test instance. And so for this webhook with the name sync webhook, it will be HTTP post at this particular path. And then here in the body, I'm giving the parameters that are needed to run the workflow. So it's my local service for my test instance of the application, the source phase, so test, target phase, the production, and the source commit. So here you see it's a metadata taken from the Argo CD application. This way, once the tests are run on this Kubernetes service here and successful, it will promote the software using this particular hash in the GitOps repository to get the source in for tests, and then promote it to production. This way, we use this hash here to be sure that if you have concurrent updates, you are not testing on one version and promoting another version. You're testing and promoting the same version, so the one that was synchronized by Argo CD. And then trigger. So when do we trigger this notification? You can use still here some metadata from the Argo CD application. So when my application synchronization is succeeded, and when my application status is healthy, then once per revision, meaning once per commit that has been synchronized, I will send my sync success test or this particular template here. So send the HTTP post. Okay, so now we have a way to be notified from Argo CD to create an event on Argo event that will instantiate our workflow to run the test and promote the software. Then we can activate this notification for basically all synchronization happening on Argo CD, but we can then also restrict to a particular Argo CD application to not have the notification checking all the synchronization happening on the platform. So to do that, in the definition of our application set, we can put a specific annotation saying, okay, I want for my notification to be sent on this particular here notification. So remember, I called it on sync success, and the name was sync webhook. Just putting this annotation here will trigger the notification when there will be an event on this particular Argo CD application. Okay, so now we can test that. So we have this nice UI that is the Argo Workflows UI, where we can see the workflows that have been run and find everything about our events. I can see my event source, my sensors. You can find a lot of information, and what will interest us is to be able to see the workflows that are run. So to do that, we'll start by bumping the version of the application from 1 to 2 in tests and see what happens. So in my test value here, I will just bump from version 1 to version 2. So just pushing it here. So now we'll see that Argo CD will watch for the changes and start refreshing and deploying the application. Now you see it's progressing, and it will start deploy the version 2 of the application. You see it's deploying it right now, 2.0. And once it's synced and healthy, we should have a workflow that is running now. So if we refresh here, we can see workflow has been instantiated and it started to run. So the first step here will be to run the integration step. So you can see the detail about the pod that is running. You can even check for the logs here if you want to see them. And you see here this particular version 2 that was returning a wolf instead of a regular pet. The test failed, so it's happening in red here. You can check the logs, and it's saying my test failed because wolf is not a dog, or it's not a cat, it's not a bird, so test failed basically. And the promotion was skipped, so the application was not promoted to production. So that's what we wanted to implement. So now that we've seen the workflow promotion, let's talk about a bit about the canary, because it will be the next step that we'll have for the next version of the application. So you remember, Argo rollouts will use some ways to be able to only distribute the new version of the application only to a fraction of the end users. So what we'll mimic here is some user traffic on the production ingress. So to do that, I've built this small UI that is inside the project as well. You can deploy it, and it can shoot traffic. So then displaying the number of cats it receives, dogs, birds, and this little skull here, it's the number of errors we receive on the API. So you can see if I shoot it now, I only receive dogs because it's version 1 of my application that is deployed in production. So now how do I do this canary testing for my application? So I included it as part of my Helm chart. So what we do to give Argo rollout the control over the deployment is to create a rollout resource. And this rollout resource, it just references the deployment that is usually used by the application, and adding then a strategy that here I've let the user define in the values. And also what you need to do in the deployment itself, the only change is to change the replicas to 0 if you want the rollout to handle the deployment. So here you can see I've put a condition: if the rollout is in the build, I put the replicas to 0, and then it lets the rollout resource actually control the deployment. Then in the values of my application for production only, I'm enabling the rollout and providing the strategy. So here it's a canary, and I'm referencing then an analysis template. So it's a kind of analysis I want to run to check if my application is healthy, so if my canary is working well. So here it's referencing a template that is called HTTP server success. So let's check it. And what it does, this analysis template, it's just querying my local Prometheus service and sending a PromQL operation. So basically what it does, it's comparing the success rate. So you can see for the metric called HTTP server request second count, with the outcome being a success over all the rest, all overall traffic of the HTTP server request second count. And this is for the baseline. I'm using the stable hash that I take as a parameter to only get the stable version in production. And then I'm subtracting here to the rate of the latest hash, being the canary hash. And I'm taking all those arguments here as parameter of my analysis template. So it's just a template as for the workflow template. And we need to instantiate them when we do a rollout. And so we reference in our rollout strategy for Canary this particular template that we want to run. We give some the value for the argument it needs. So here I'm giving the name of my container that is used in my PromQL. Then I'm getting the hash from the stable version and from the latest version. So it's some thing that is provided by Argo rollout. So you don't have to build this kind of logic yourself. It's giving you the hash for the stable version in production and for the Canary. So you can get it directly like that. And then I'm defining the steps of my canary. So first, I will set the weight to 20% of my traffic to the canary. Wait for 30 seconds. Behind the scene, remember, my analysis will continue to run and check that my success rate in my canary is the same as the one I have in production. Then if after 30 seconds, if everything is fine, increasing to 40, then waiting to 60, waiting again until we put everything on the canary. And then we remove the previous version of the application. Then the rollout is considered as successful. If there is any failure in my analysis during this process, it will stop the canary there and scale down the canary and put then again 100% of the traffic on the previous version of the application. Then I just need to give Argo rollout a few information about my services to be able to switch between stable and canary. So I've created two Kubernetes service for my application. So one step for the stable, one for the canary. It's in the template here if you want to check. Basically, the selectors are the same. They are just selecting with the same labels, and Argo rollout will take care of putting the hash of the stable and canary version inside each of those services for me. So I don't have to do anything. Argo rollout is doing that logic. And then give him the for Nginx. So saying, okay, it will be Nginx that will be in charge of splitting the traffic between stable and canary, and giving my production ingress. And Argo rollout will take care of creating another ingress that will be used for the canary, and then dispatching traffic between the stable and the canary. So we see not a lot of logic to implement, just analysis to implement and check that your application is running fine, and then Argo rollout is handling most of the logic. So now let's push version 3 of the application. So now checking that Argo CD is detecting the change and applying it in tests. So now it's deploying the new version, the version 3 in test phase, and we should have a new workflow running. Here it is. So again, run the same steps. So you see, this time the tests were successful because it's returning either dogs or cats or birds, and then it's promoting to the next phase. You can then check in production that the change is detected, so you can see that there was a commit for the automated promotion to production, and so now it's deploying the new version as a canary. and it's running now an analysis. So let's get into the details. You can see the app is suspended while the rollout is running. So it's not healthy. So you know that something is going on in your platform. So you have also a UI for Argo rollouts, so you can check what's going on. So you can see that I had my application version 1.0. I'm promoting the 3.0, and then it's running the canary process. So you see it has put the weight to 20%, did a pause, 40%, now it's doing a pause again, and analyzing here is running. If I click, I can even check the different measurement that it did. All were successful here. It's continuing the process. And in the meantime, you can see on the UI that I'm starting to receive some cats and birds as well at the docks, with a few percent, because it's only for the few percent of the production. And then you can see that everything was successful, the analysis is successful, so it's starting to scale down my version 1 of the application and put all the weight on the new version, so the version 3 that is becoming the stable version. So my canary now is successful. Now let's bump to the latest version of the application, so the version 4 that is introducing some random failure on the API, something that will not detect with our integration tests, so automated test campaign, because usually in test you have some retry mechanism to cover some instability on the platform, this kind of thing. So it's to mimic the kind of issue you would not see in test, because it's only really happening very few times. But you want to be able to detect it in production, even if it's happening really for very few percent of the traffic. So again, it goes through the test deployments. I will have a workflow as well that is starting, running the tests. So I was saying I've put some retry in my test, so to cover, let's say, some enforcing issues. But here it's so it's this kind of thing we will miss, but we want to see happening in production. So it will promote then to prod. Here it is. And now you can see a new commit has been done promoting the application, and a new rollout will happen, and analysis going with it. So let's go in our Argo rollout view. You can see this time the stable is the 3.0, my canary is the 4.0, and we'll start measure what's happening on the platform. So if I go back to my little test UI, you can see I'm receiving cats and dogs and birds, and I'm starting to receive very few failure on my API. This is the kind of thing I want to be able to detect using my canary mechanism. So if I go back to my Argo rollout UI, you can see the analysis failed. So this is just a trigger that will say, okay, stop the canary and roll back everything to the previous version. You can see that now it's starting to scale down the canary. It will do it in a few seconds, just giving the time for the ingress controller to switch back all the traffic before deleting the pod. And it will switch back everything on the stable version. You can see the actual weight of the canary is 0, so everything has been switched back to the 3.0. So you can see we are using that. We have been able to identify a very few percentage of the traffic that was in failure here, and roll back to the previous version of the application and not impact our end user, or impact it at least for the minimum amount of time as possible. So that's it. So we are able to quickly and easily implement GitOps, continuous deployment and delivery pipeline. So by using Argo CD as a GitOps deployment tool, so able to watch our Git repository deploy everything, so the application, but also all the infrastructure around, all the controllers, and also all our manifest for the promotion workflows and our canary tests. We're able to implement a promotion workflow to validate the changes automatically when a new version is deployed on tests, and promoting it to production without any human intervention. And then when going to production, we're able to just deploy progressively the new version to the end user to check that everything goes fine and detect any issues that could occur in production, and automatically again roll back to the stable version if anything wrong is occurring. And around that, you see everything is automated. And you can implement some notification in every step of the flow so that your DevOps are notified when something goes well or something goes wrong on your platform during the promotion, the synchronization, Argo CD, during the rollout. So this way you are just one and alerted when something goes wrong, but you don't have to do everything by yourself. Now everything is automated. So thanks for watching and see you next time.